Right, this is another video on the 2020 January paper. This is going on section B. So we're going to start off with multiple choice. In fact, the first thing I am going to do is I'm going to focus the camera. If that makes it any clearer. There we go. Right, so identify one method that would be used to find the density of a material. Okay, I'm going to go over this by process of elimination. Density, material, physical. Okay, this is a mechanics section. Kirchhoff deals with electronics. Okay, electronic principle, so we'll see him in section C. Therefore, I can eliminate him. Okay, we've got Pythagoras' theorem. Pythagoras dealing with lengths. Okay, so I can get rid of that. And Newton deals with forces. Linked a bit to density, okay, but not directly. And then we've got Archimedes' principle. Okay, Archimedes' principle is going to be the correct answer for this one. Okay, a couple of little things about Archimedes, one of which uses the cup experiment. So you fill a cup full of water and then you put an object into that cup, and then the amount of water that then displaces it can then be used to then calculate the density of your object, okay, via a couple of calculations. Question 7, identify the unit of measure for shear stress. Now, shear stress, okay, is like any other normal form of stress, so direct stress, okay, and stress is measured, or the formula for it is force over area, and you can find this in your formula booklet. And if you know what the units for forces, or standard units for forces, you know it's newtons, and the standard unit of area, which is going to be meters squared, then you can then have the unit newtons per meter squared. And you're just simply looking for that as an answer, and there you go, it's going to be answer D. Okay. These per seconds, if you want to go process elimination per second, you could definitely eliminate straight away because you're looking for a material property that doesn't deal with seconds. But this one over here, A, is the only other one that you could potentially struggle with. All right, it is very similar to answer D. Okay, right, moving on. Right, question 8. This is our first set of SUVATs that we've come across so far, if you're watching these videos in order of them being made. Okay, so quite happy that we've finally got some SUVATs. A car is on a road with a set of traffic lights ahead. Car is at rest. It accelerates for 8 seconds and it decelerates at 4 meters per second squared, and then it's at rest. The car starts from rest. The car then accelerates at the car then accelerates at a constant rate of 3 meters per second, so new information for 8 seconds. Calculate the velocity of the car after the 8 seconds, so only up until this point here. So, exam technique for SUVAT for me is going to be writing S, U, V, A, and T down the side of my page. We don't have the distance, and we also don't need the distance. U, the initial velocity, well, it says it's at rest, therefore that's going to be 0. Final velocity, well, we're trying to calculate the velocity after 8 seconds, so that's going to be the final velocity. The acceleration was given to us, which was 3 meters per second squared, and then time, it said it was accelerated for 8 seconds. So I need to find a SUVAT formula in my formula booklet that uses the letters V, U, A, and T. Now, fortunately, there is a formula in that exact order: V equals U plus A, T. Okay. We're trying to solve for V. We've got an initial velocity of U, therefore 0 goes in that place there. 0 plus 3 times by 8, and that equals our velocity. Smarten this side up. Velocity is going to equal 0 plus 3 times by 8. 3 times by 8 is 24, so 0 plus 24 is going to be 24, and that is going to be in meters per second. So write that on your answer line down here, 24 meters per second. Right, we're then told the car then deaccelerates at a constant rate of 4 meters per second and stops at the traffic lights. Okay, as we saw previously up at the top with our diagram. Calculate the distance travelled by the car while it is deaccelerating. So we're only worried about the distance from this point, this midpoint, to the very end. Now we need to write a new set of suvat down because the parameters have changed. Of course, we were accelerating initially, now we're deaccelerating, so we need to take a new set of parameters. We're solving for s, which is the displacement, the distance travelled. I'm going to put some equals there. Our initial velocity we know because we just calculated it. Okay, so initial velocity is 24. Our final velocity, well, it says it is at rest, therefore it must be at 0. And then we've got our acceleration, which we were told it is going to be deaccelerating at -4. Therefore, this value here I need to put as a minus, because this is our value for accelerating. The opposite of accelerating is deaccelerating. Its negative form means it's deaccelerating. Now I need a formula, suvat formula, that uses the letters S, U, V, and A. And there is the formula V squared equals U squared plus 2 lots of AS. This needs to be rearranged in a moment. The first thing I am going to do is substitute some numbers into this, and then I'm going to rearrange. V squared equals 0, equals U squared, which is 24 squared, plus 2 times by the acceleration, which was -4. And then I'm going to then times by the S. What I'm going to do quickly is I'm going to smarten this side up. I've got 0 equals 24 squared. Let's just quickly chuck out a calculator. 24 squared gets me 576. And that's going to be 2 times by -4, which is going to get me -8. Now if I'm going to remove this plus -8, I'm just going to leave it as -8. And that's going to be -8 lots of S. Now what I'm going to do, I'm going to add plus 8s to both sides, therefore eliminating this part and getting something over here other than 0. So I'm going to get 8s equals 576. And then I'm going to have s on its own. I'm going to divide 8 on both sides, therefore leaving my answer as, I believe it is 72. I'm just going to double check my calculator. 576 divided by 8 equals 72. There you go. Answer is 72. Apologies, you weren't able to see that last little bit there. Okay, so I divided both sides by 8, then get s on its own. 72 is my final answer, so give your answer an appropriate unit, so we need to then say it's 72 meters. That is going to be question 8 complete. That is a total of 6 marks done for that question. Right, question 9. A bicycle wheel rotates at 120 revolutions per minute. The radius of the bicycle wheel is 280 millimeters. Calculate the angular velocity of the bicycle wheel. So if you're like me and your angular velocity, your angular parameters section of this exam is a bit rusty, I recommend you just grab your formula booklet now. There's going to be a couple of things that we're going to do. Okay, I'm just going to pop that to the side there just for a moment. I've got access to it if I need it. So there's some conversions I am going to do before I deal with anything else. And the first thing I'm going to convert is the 280 millimeters. I'm going to make that into SI units, okay, because that's going to make my life a little easier later on. So 280, let's write this down. $280 millimeters is going to be equivalent to 0.28 meters. Only other thing I could potentially do is to work out the revolutions per second, the RPS. Okay, I could do that. I am now just going to focus on this, calculate the angular velocity. angular velocity should be the symbol, that weird symbol W. Anyhow, first thing we're going to do, W. This is going to be equivalent to the RPM times by 2 pi 60. You may be wondering, what am I actually doing? I'm taking the information from my angular frequency. Angular frequency is W equals 2 pi frequency. Okay, I'm taking this information and converting it into this right here. RPM. Our RPM is 120. Okay. And by timesing it by 2 pi over 60, I can take this 60 across over here and divide it. Okay, so then I'm going to get the value 2 times by 2 lots of pi, still equals omega. Omega? Can't remember what that letter is.
You'll need to unlock your iPad first.
Apologies, Siri's going off. There we go. This symbol here, 2 times by 2 pi, that's going to get 4 lots of pi for that right there. And with that, I can write that whole value out properly. 4 times by pi equals 12.56637. Another way of doing this, okay, which was when I said I wanted to convert this RPM. Let's change this RPM to revolutions per second. So 120 divided by 60 to get it per second is going to be 2. Okay. Now once I've got it by 2, I can apply it to that formula I just looked at, which was W equals 2 pi frequency. This 2 here represents the frequency, which is how many times it rotates per second. I've got it in rotations per second, therefore that is the frequency. Alright, 2 times by pi times by 2 will still get me 4 pi. Okay, this is just a bit of a convoluted way of doing it. This is far simpler. 2 times by pi times by 2, which still equals 4 pi, which therefore then gets me the same value of 12.56637. So let's make sure I place this down in the answer section. Can leave it as that, and it's a velocity. Okay. But we need to make sure we leave it in terms of rads per second. Right. We now need to calculate the centripetal force. Just realised that my camera angle was all wobbly. Right, calculate the centripetal force, centripetal acceleration. Gosh, I need to be able to read. Right, if we have a look, angular parameters, centripetal acceleration is at the top here, and we've just been dealing with this right here. Okay, this little symbol, that weird Greek W. I've just worked it out. And we've got R, which I just converted earlier. Okay, it's very useful to have it in meters, okay, because we can get some very nice units out of it. Acceleration. Acceleration equals W squared times by R. Right, acceleration wants to be in meters per second. And we've got this, rads per second, times by 2, it's going to be squared, sorry. So these units are going to be per second squared, which is ideal. What I'm going to do is I'm going to substitute the values in of 12 point. In fact, let's get rid of that. That's messy. 12.566 squared times by the radius, which we worked out to be 0.28 meters at the very top there. Let's see just there. Okay, times by 0.28. The reason for making sure that I do an SI unit initially is that it makes my life easier when I'm trying to make the units down here for the answer. I'm going to use my complete answer here rather than my abbreviated one. So I'm going to go answer squared times by 0.28, and then I'm going to press the equals, and that's going to be my final answer, which is going to be 44.216. Okay, I'm going to leave it as that, and that's going to be meters per second squared. And then I'm going to go to the very bottom of the page and write that as my answer, 44.216 meters per second squared. Lovely. Moving on to question 10. Question 10. Explain what is meant by the term non-concurrent forces. Right, let's quickly have a look at non-concurrent with a diagram. I'm going to go with quick example of a seesaw. Here's my fulcrum. Here's a seesaw. I can have a weight, a force acting down here. I can have a force acting down here. Okay. Very simple drawing, just to explain what I mean by non-concurrent. This situation is a system. Okay, this is a system. Nothing else is interacting with it, or at least this is an ideal situation when nothing else is interacting with it. Okay. Now, this system of forces, because I've got force 1 over here and force 2 over here, they do not act at the same point. Because they don't act at the same point, they create something called a moment. Okay, moment because there is a perpendicular distance from the point at which this force can actually react with. Okay, and those are the distances there. It's very different to, say, a mass like this, and say I'm pushing it this way and then someone else is pushing it that way. Obviously this is going to be in compression, but if we were trying to move this object, our forces would be acting at the center of mass being this specific point, so these would be concurrent. Okay, these forces over here are non-concurrent because it's still a system, but they aren't acting at the exact same point. It isn't taking effect at the exact same point. So, that being said, let's quickly write a definition for the two. A system of two or more forces, that do not act at the same point and therefore can, I don't want to say that they produce, and they can, I don't want to say the word produce, I am going to reuse it then, produce couples or moments. I use the word couples here, so let me quickly just explain what a couple is. I want you to imagine like a seesaw, but this time just imagine, say, a dowel, a stick, okay, that goes into a piece of wood. Okay, this is essentially its axis. All right, if I apply a force here of say 10 newtons and a force over here of 10 newtons, and these two distances are equal, so I'm just going to give it the letter D. Make it the letter D. Essentially, what you created here is two moments that act in the same direction, and by direction I mean anti-clockwise. And if they're both going in it's a couple of forces that act in the same direction, so anti-clockwise in this situation, and therefore they will then just spin. Okay, moments tend to oppose each other. Okay, couples need to be the exact same force and distance away. Okay, and therefore you then get the exact same moments occurring in the same direction. Okay, so that's a couple. All right. Not necessarily needed for this question, but always, good to show off when you can. Right. Question 11. Question 11. Love these questions. Okay. These questions are definitely more of your mechanics with maths, as in the A-level math subject. But we've got it here today, which is great. A packing crate is placed onto an inclined plane. The inclined plane is friction-free, zero friction. Lovely stuff. We've got an acceleration acting down this way. We've got a force due to gravity acting down here. And we also have a normal force acting from the slope. Therefore, the object doesn't just fall through the ramp for no good reason. Okay, so there is a force resisting essentially this direction. The force due to gravity, Fg, acting on the crate is 75 newtons. Calculate the acceleration force acting to move the crate down the slope. Right. Force due to gravity is always, in this situation, going to be the biggest force. Okay, it's the biggest. Now, I want you to draw an arrow going perpendicular to this surface from this point though. So it's going perpendicular through the surface. And I want you to stop around about just here. I then want you to draw a parallel line to this arrow here, connecting this end and this end up. Now, I use the word perpendicular, I use the word parallel. Therefore, this angle here must therefore then be 90. Right, you got Fg just here. Fg is this length due to gravity. This is Fn, which is going to be force normal, the force that's normal to this plane. And then therefore, you're going to have Fa as this length over here. Now, it's a very diddy drawing, but it gives you all the information you need. You then can take this degrees, this 30 degrees, and you can then place that 30 degrees as an angle in this top corner here. And then I want you to look at it and then specify which one is going to be the hypotenuse, the opposite, and the adjacent. Well, this side over here has two angles, therefore this is going to be A. This length is the longest length, therefore must be the hypotenuse, and to back that up, it's opposite this right angle here, so this is going to be H, and therefore FA is going to be O. We need to solve FA, okay? So let me go to my FA, okay, is going to be solved by, right, let's talk about O. O, what information do we have? Well, we don't have F and we haven't worked it out, but we do have Fg. Fg was 75 newtons. 75 newtons equals Fg, which in this case is going to equal the H. We are solving for O, but we don't know what it is. Okay, but we do have the information of, we're looking for O, we've got H, we've got the angle, therefore we're going to be using the trig for sine, theta, opposite, and hypotenuse. Here's my triangle. I'm looking for the opposite, putting from over that, therefore it must be sine theta times by H to get me my answer. So let's put it over here. H is 75 times by sine of 30. I'm going to put it on my calculator. See what I get. 75 times by sine 30 is equivalent to, I believe it's going to be 37.5 because I think sine 30 is a half times by the 75. But let's just see. Sine 30, 75.5. Yeah, that's going to be 37.5. That's going to be newtons. If you have any questions about this triangle, please just leave it in the comments. Okay. Yep. Let's just place our answer at the very bottom of the page, making sure we include our units. Right. That's question 11. Complete. Let's move on to question 12. Question 12 is going to be our last question for section B, as it says, section B, total at the bottom of the page. Right, the storage tank has a capacity of 18 meters cubed. The tank is filled with water through a gradually tapering pipe that runs full. Very useful information, okay, it means we can use our fluid principle. Equations for this: the inlet diameter of the pipe is 50 millimeters. The outlet diameter is 30 millimeters. Assume that the water enters the pipe with a velocity of 2 meters per second and the tank is empty. Calculate the time taken in seconds for the tank to fill. Right. We're going to need to use something for volumetric flow. So, there's a couple of steps to this. There's the formula for continuity of volumetric flow, which is in your formula booklet, which is the area, cross-sectional area of your inlet times by the velocity of your inlet is equivalent to the cross-sectional area of your outlet times by the velocity of your outlet. But you've also got the formula for volume flow, okay, simply just being volume flow is equivalent to A times by V. Now, we've got a max capacity of 18 meters cubed, which is my volume. My flow is therefore per second. If I figure out how many seconds it takes, or the volume flow, I can then use that to then calculate how much time it's going to take to fill this. Okay, I'm going to start with this section first, make sense of this, and then we'll then talk about this bit and how we can manipulate the numbers here to then get our answer for time taken. Okay, so AV, let's get substituting these values in this exact form here. The inlet diameter of the pipe is 50 millimeters. So, inlet diameter. We need to make sure that is an area. Okay, so I'm going to convert this 50 millimeters into meters first of all. 50 millimeters, let's write this over here, 50 millimeters equals 0.05 meters. That's diameter, we need area, therefore 0.025 meters is our radius. Okay, then we're going to apply pi r squared. Pi r squared equals A. So we're going to have pi times by 0.025 squared equals A. Let's check it in the calculator. This is going to be a very small number. However, I do like having everything in SI units. We're going to get 1.963495408 times by 10 to the minus 3. That's a lot of numbers there. Okay, so we can say that we've got A1 done. Velocity, we've got the velocity for the inlet, which is 2. Right. And in fact, there is no point in trying to calculate this conversion rate because the question says it runs full. Therefore, I know that the area and velocity, the volume flow rate for the first part is going to be the same as the volume flow rate for the second part. So there's not even a point in trying to solve that. I've just converted this into meters squared. So I'm just simply going to times this number by 2. So I'm going to have 2 times by this value, 1.963495408 408 times by 10 to the minus 3. Okay. Just check to my calculator. Answer times by 2 equals 3.92. 6,990,817, right, times by 10 to the minus 3. Okay, I worked out my area in meters squared. I've got my velocity in meters per second. So when I do meters per second, sorry, meters squared times by meters per second, I get this thing called meters cubed per second, which is the units for volume flow rate. Meters cubed per second, in terms of its units, okay, it's split down its units, is essentially volume per time. I've got a volume of 18 meters cubed. And I'm trying to work out the amount of time it takes to get this set of units here, which will equal this value here. So in other words, it's going to equal this 3.92690817 times by 10 to the minus 3. Therefore, what I'm going to do is I'm going to rearrange this. I'm going to take this question mark, okay, going to give the value, the symbol T for time, okay. To get rid of, in fact, let me write it like this. And I'm just going to call it 3.92 times by 10 to the minus 3 for the time being, even though I've got the exact value in my calculator, just for simplicity reasons, okay. I'm going to times both sides by t to get the denominator rid of, and then I'm going to divide both sides by 3.92 times 10 to the minus 3, so then I can then just solve for t, and then I can then get my answer. 18 over 3.92 times by 10 to the minus 3 equals t. We're trying to solve for time t. As you can see, this is going to work nicely. So then we're going to grab the 18 over my answer, because I had the answer of 3.926990,817 times by 10 to the minus 3. Saved. Press the equals. I get the answer 4,583.66. Put that in this answer, okay, in, I don't know, as you can see, I've got more digits than I need in here. Just round it to the first decimal place. So 4,583.7. Okay, and then make sure you write your units for seconds. As everything was measured in seconds, make sure you write at the very, very bottom. I'm surprised at how little calculation you need to do for this 9 marker. Okay, but you did see me stutter a couple times, so it must be a case of the concept is just very alien and tricky, and therefore they gave you so many marks for it. Right, that's it for section B of the January 2020 paper. I'll see you in the next video.